So what we're going to take a look at here is factoring quadratics. We had talked a little bit about this in class and what this means, but today we'll actually look at the process for how we're going to do that for quadratics with an a value that is equal to 1. As what we're going to look at when we look at when we look at trinomials here, we're going to look at quadratics that are in standard form. And when we look at something that's in standard form, there's going to be a process for it, and it's going to be a 4-step process every single time we go about factoring these. Now, you've been shown in class a little bit of what this process looks like and how it should look in the end. The first step in this process is going to be to look for a GCF. So I'm going to look at the A value, the B value, and the C value and see if there's anything that I can remove that some factor that they all share. If I'm looking at these, I have 1, 2, and 1. Looking at those, there's nothing that they all share. There's no greatest common factor, so there's nothing that I'd be able to do quite yet. Next, what we're going to do is create an X for with specific values to help us factor. Now, it's always going to go this way in this X. This is called the X method. We're going to put the B value on the top, and we're going to put A times C on the bottom of the X. So looking at this, remember back to when we look at something in standard form, what our coefficients stood for. Alright, 1, 2, and 1 here, A, B, C. Our B value, in this case, is 2. And on the bottom, we're going to have A times C. 1 times 1 will give us 1. Okay? That's what we're going to go through and start this with. Now, the tricky part is what goes here and what goes here. What we need to look for is we're looking for two numbers that add to this top number and multiply to whatever number's on the bottom. So we're looking for two numbers that add to 2 and multiply to 1. Now this goes back to those number sense puzzles that we started. That's why we did those. So what we're looking for is two numbers that add to 2 and multiply to 1. And to go through and do that, you're going to use your multiplication. So if we look at our multiplication table, we see that the only two numbers that are factored multiply together and give you 1 are going to be 1 and 1, which, nicely enough, add up to 2. So we're able to put 1 and 1 in these two spots on the sides of the x's. Those are going to be our key values. Okay, and it's important to remember the 1 and the 1. Because now what we're going to do is we're going to use those two numbers. We're going to rewrite our quadratic as binomials with the same coefficient as x squared. And if I look at that, my coefficient here is 1. So I'm going to write two binomials. Okay. And the other number that's going to go here, the second half of the binomial, is going to be whatever numbers we found. Okay, so that means x plus 1 and x plus 1 is going to be the factored version of x squared plus 2x plus 1. Okay, how you can check that is by doing this. You can go through and you could FOIL. Remember what that stands for. First, outer, inner, last. You go through and you multiply the first terms, the outside terms, the inside terms, and the last terms. X times x is x squared. X times 1 is 1x. 1 times x would be 1x again. 1 times 1 is 1. I combine my like terms. Works out perfectly. So that means the factored version of this is x plus 1 times x plus 1. That one ends up going through and checking out. Okay, again, all this is just a big number sense puzzle. I'm going to go through the same process. Step 1, look for some greatest common factor. If I look at these three things, I have none. 1, 6, and 5, they share no factors. So I would be done here. Just like the last one, create an X field with specific values. So I'm going to look at A, B, C. Our A value is 1, our B value is 6, and our C value is 5. So just like last time, the same process. B on the top, A multiplied by C on the bottom. B in this case is 6. A times C would be 1 times 5, which gives us 5. Now, I'm looking for two numbers that add to this top number and multiply to this bottom number. So, I need to look across my multiplication table. So now, if I take a look at my multiplication table, I'm looking for two numbers that multiply to 5. This looks 5 and 1. Same thing over here, 5 and 1. So now what that means, if I look at these, I add them together, 5 plus 1, yeah, that gives me 6. This is the same number over here, so that would be 6. That works out perfectly. 5 and 1. 5 times 1 gave me 5. 5 plus 1 gives me 6. These are going to be my two factors, the numbers 5 and 1. So what I'm going to go through and do is I'm going to rewrite this quadratic as x plus 5 and x plus 1, because my coefficient is going to stay the same as x squared, which was 1 here. X plus 5 and x plus 1. This is the factored form of x squared plus 6x plus 5. And we could check that. We could check and make sure by using that FOIL method. And remember, that stands for multiplying the first, outside, inside, and last terms. Okay, x times x, x squared, x times 1, be 1x, 5 times x, be 5x, 5 times 1 gives you 5. Combine my like terms. Works out nicely. Okay, this is the same exact thing as this. So that's telling me the factored form is x plus 5 times x plus 1. Because again, remember, when you're factoring, you're not creating a new expression, you are just producing a new form of that quadratic. Alright, last but not least, let's do this one more time, because I know this is so enjoyable. But what we would look at, another one of these, okay? GCF, that's the first step we're looking at. I don't see any here. A, B, C, none of these numbers share any factors. It's not like I could pull a 2 out. It's not like it was something like 2x squared plus 2x plus 4. If I looked at that, I could say, oh, all of these things share a 2. I can remove that from it. Okay, and that's something we're going to do in a later video and something that we're going to progress to later on, but just know that's what we always look for first, some kind of GCF. And in this case, we have none, so we move on. Now, same exact process. Identify A, B, and C. A is 1, B is 7, C is negative 8. Okay, this one's going to be a little bit different because we have the negatives. Remember back from our number sense puzzles, these ones are going to be a little bit trickier. So, just like the last few times, we're putting B on top, A times C. B would be 7, and then A multiplied by C would be negative 8. So I'm looking for two numbers that add to 7, multiply to negative 8. So, now again, we have to think about, we have to look for numbers that are going to multiply to negative 8. So if I find all my 8s, this is an 8, that's not 8. Here's an 8, here's an 8, and that's it. Okay, that's the only way, oh, I'm sorry, down here, forgot about this one. Okay, so now if I take a look at this, what we're going to have to go through and do is we're going to have to say, okay, the only way it could be negative 8 is if one of these numbers are negative. So let's make this top row negative. Okay, so that way, if we go through negative, okay, now that works out because negative 1 times positive 8 is negative 8, negative 2 times positive 4 is negative 8, negative 4 times 2 is negative 8, negative 8 and 1 also gives us negative 8. So, and again, you guys should have this one with all the negatives on it. I just didn't, so I'm making a bootleg version of it. But if I'm looking at all of these, so that means the possible factors for me are going to be negative 1 and 8, negative 2 and 4, negative 4 and 2, and negative 8 and positive 1. Those are the only possibilities. Those are the 4 combinations of numbers that multiplied together give us negative 8. So let's go back to here. We're looking for numbers that add to 7. If I look at all of these, this adds to negative 7. Those two would not work. This adds to negative 2. Would not work. Adds to positive 2. Would not work. These two numbers add to positive 7. That's what we're looking for. Negative 1 and 8 would be our magic numbers. Negative 1 and 8 would be. Okay, those are two numbers that add to 7, multiplied to negative 8. So what that's going to mean for us, we're going to go through at x minus 1, x plus 8, because again, we're writing two binomials with the two factors that we had just found, and they have the same coefficient as our x squared term here. So this would be our factored form, x minus 1, x plus 8. If you don't believe me, we can check. Okay, it's always a good idea to go through and use this technique when we are checking, x times 8 would be 8x, negative 1 times x would be negative x, negative 1 times 8 would be negative 8. Combine our like terms, bada bing, bada boom, and it's the same exact thing. So that works out fantastically. X minus 1, x plus 8, that would be our factored form of this. Again, it's the same process every single time when you go through and do this. And it's identify the GCF. Next, you're going to use your x method. Then you're going to actually write out the two binomials, and then you check. Okay? Now, the last 4 problems I want you guys to try, and then we're going to end up going through and completing a worksheet on factoring.